Hey everyone, welcome back to the channel. So in the last episode, we talked about sealed classes versus enum versus data class. And a lot of you asked me one question, that is, what about sealed interfaces? Okay. So today, let's answer it properly. No theory overload, no boring definitions, just the real life examples, some Android use cases, and clarity that actually works or actually sticks. All right. And trust me, once you get this, sealed interfaces will feel very natural to you. Okay. So the agenda for today is we will cover the few topics about related to sealed interface, like what is a sealed interface, why Kotlin needs it, sealed interface versus sealed class, some layman examples that you will remember, some Android use cases as well, and the common mistakes that usually developers do, followed by the final takeaway. Okay, so let's begin with the definition. What is a sealed interface? So a sealed interface is an interface that restricts who can implement it. All right, that's it. I mean, that is the simplest example or simplest definition one can have. And the code says like a data class success, a data class error, and object loading. So all three of them, which are part of the sealed interface UI states, they are extending the UI state. It is same as how you use the sealed class, right? The same way you will extend that particular class, then the same way you are extending the UI state, the interface. All right. So basically, what happens is normally any class can implement an interface from anywhere in your project, right? That's how it works. But with a sealed class interface, Kotlin says only known controlled implementations are allowed. All right. So if you see this example again, here the UI state knows exactly who its children are. No surprise implementations hiding in some random packages. Okay. So just to be, we can think of a sealed interface like a guest list for a private party, where only people whose names are on the list can enter. No random plus ones and no friend of friend. And whereas a normal interface is like an open wedding buffet where anyone can walk in. But a sealed interface is invite only. That's why we love it. Okay. Now we see the next slide. It says the section 2, why did Kotlin introduce sealed interfaces? Okay. So before sealed interfaces, we had sealed classes. That is absolutely right. They were great, but they had one limitation. And what is the limitation? A class can only extend one class. That is exactly the reason why Kotlin has introduced these sealed interfaces. So if you already extended something else, boom, sealed class is no longer an option for you. Okay, you can imagine like your class already extends view model, and you also want to extend this UI state interface safely. But the sealed class says, sorry bro, inheritance slot is already being used, so you cannot extend another class. But if it is a sealed interface, then it will say, no problem, I'll fit in. All right. So that's what the major difference between both of them, and that is why Kotlin has introduced the sealed interfaces. Now section 3, it says sealed interface versus sealed class. Let's read some key differences. The sealed class can hold state, it can have constructors, and it can have only one parent allowed. Of course, I mean this class can be extended by only one parent. That is true. Whereas the sealed interface says it does not have any constructor. Of course, the interface doesn't have. It supports multiple inheritance. Yes, that is true. And that is the reason we are using sealed interface. And it works beautifully with existing class hierarchies. All right. So this is a code comparison, guys. This is how the difference, you can figure it out if it is an interface or a sealed class. All right. So if you need behavior plus state, then you go ahead with sealed class. But if you need flexibility plus contracts, then you go ahead with sealed interface. All right. Think like a sealed class is like a family surname. You can only belong to one family. That is true. Whereas a sealed interface is like roles, like it could be employee, mentor, speaker, and you can be all three at the same time. That's why sealed interfaces are much more powerful. Okay. So slide 6 says the another one, section 4, that Android, a real world use case. So this example I've used it in the before slide as well, where a sealed interface has three different categories. Two of them has data class, of type data class. The other one is object class, which basically can be used for hiding and showing the what we say, the progress bar. And the one is success, which takes list of user type. Other one takes message of string type. All right. So this is perfect, for Stateflow or live data or MVI or MVVM. I mean, this particular use case can be used with any of them. Either I want to go with Stateflow, live data, MVVM, etc. Your UI knows exactly what states are possible. Okay. Now the section 5, the common mistakes which usually we do. Mistake 1, using sealed interface for just constants. I think enum is much more better and easier approach, right? Mistake 2, putting business logic inside implementation. I think that is a bad separation, right? Mistake 3, using sealed interface when you actually need constructor or state. I think we can go ahead with sealed class, which is a much more better option, right? So guys, basically what I'm trying to say is tools are not bad, but misuse is actually bad. So we have to be very careful in our understanding that when we are executing in our code base, we should actually know the major difference between the sealed class or a sealed interface. And according to the business logic, we should go ahead and choose one of them. So section 3 says, when should you use sealed interface? When you should use is when you want to restrict, when you want restricted implementations, you want multiple inheritance, you are modeling UI states or events, or you want compiler exhaustiveness checks. But when to avoid, when you need heavy state or constructors and you only have fixed constants. So maybe when you have constants, as I've mentioned in the last slide, you can go ahead with enums. When you have something in constructors, of course, you have to go ahead with the class. Don't use interface because it will not support any constructors. All right. So the final takeaway: sealed class is equals to behavior plus data. Remember this one line: sealed class is equals to behavior plus data, whereas sealed interface is equals to contract plus flexibility. So if you remember just this, you are already ahead of 80% of the developers. Okay. So guys, that's it. If this explanation made sealed interfaces finally click in your head, hit the like button. It really helps the channel. And drop a comment if you want a real world project example using sealed interfaces with Stateflow. Alright, I'll see you in the next video.